Every night the sky is full of stars, and every night the universe remains silent. No signals, no visitors, no evidence of arrival. This silence is not mysterious anymore, it is quantitative. The popular belief that aliens must eventually arrive rests on a single emotional shortcut. The universe is large, therefore life must be common, therefore contact must be inevitable. Physics rejects this chain completely. Size alone means nothing when distance, energy, time, and causality act together. Space is not an open road waiting for better engines. It is an environment that actively destroys complexity. Radiation damages information. Vacuum eliminates biology. And distance erases intention. The universe does not merely make travel difficult. It makes arrival meaningless. This is where the optimism collapses under what can be called the Feynman reality check. Richard Feynman built his entire worldview around a brutal principle. Nature cannot be negotiated with. You do not get exceptions because an idea feels reasonable. If the accounting does not close, the idea fails. Applied honestly to alien visitation, the numbers do not bend, they terminate the concept entirely. The nearest star system is more than 4 light years away, a distance that sounds trivial until translated into physical terms. Light itself requires over 4 years to cross it, and no object with mass can reach light speed. The fastest spacecraft ever built by humans moves so slowly relative to that limit that even unmanned probes would require tens of thousands of years to arrive. Crewed missions are not merely impractical, they are structurally incoherent. Life support, error accumulation, social continuity, and material degradation all scale against long duration. A journey that outlives civilizations is not exploration, it is abandonment. Science fiction treats faster-than-light travel as a future engineering milestone. Physics treats it as a violation of causality. Special relativity is not a technical suggestion, it is a structural rule of reality. Allowing faster-than-light motion produces paradoxes where effects precede causes and time loses order. Any universe that permits this becomes logically unstable. Feynman's standard applies cleanly. If an idea breaks reality, reality forbids the idea. No amount of intelligence, advancement, or time grants exemptions from causality. Even if we grant a fantasy scenario where a civilization reaches a significant fraction of light speed, energy becomes the executioner. Accelerating even a modest spacecraft to relativistic velocity requires energy comparable to the sustained output of stars. This energy must then be spent again to decelerate. At those speeds, interstellar dust microscopic grains carry kinetic energy equivalent to explosives. Space is not empty enough to be safe. Shielding adds mass, mass adds energy cost, and the loop closes with no solution. Engineering does not fail here because it is insufficiently advanced. It fails because the environment scales faster than capability. Time is the most understanded barrier. Civilizations do not persist for geological spans, let alone cosmic ones. Humanity's technological phase is measured in centuries, not millions of years. The overlap required for 2 independent civilizations to both exist, develop interstellar capability, and intersect spatially within the same temporal window is vanishingly small. The universe is ancient, but technological civilizations are brief flashes. Expecting synchronization across interstellar distances is not optimism, it is statistical denial. This reframes the famous question of where everybody is. The correct question is why we ever expected anyone to be here. The expectation of visitation is rooted in narrative instinct and anthropocentric arrogance, not in physics. When the constraints are applied without compromise, alien arrival shifts from unlikely to effectively impossible. This is why stories of unidentified objects flourish while evidence does not. The human mind fills silence with intention, patterns, and agency. Physics fills it with limits. Extraordinary claims collapse under ordinary conservation laws, and Feynman's rule remains undefeated. If it disagrees with experiment, it is wrong. The universe is not crowded, it is fragmented. Galaxies are not communities. Stars are not neighbors. And civilizations are not participants in a shared conversation. They are isolated islands, separated by distances that erase contact before it can begin. Aliens do not fail to arrive because they choose secrecy or restraint. They fail to arrive because the medium between stars does not permit meaningful traversal. This realization is uncomfortable because it removes external actors from our story. No watchers, no visitors, no inheritors of greater wisdom, just local intelligence confined to local consequences. The implication is not despair but responsibility. If intelligence is rare and isolated, then its loss is permanent. There is no replacement, no backup, no cosmic continuity. The silence above is not waiting to be broken. It is the default state enforced by reality itself. Man, what shall never arrive. Once biological travel collapses under physics, belief retreats to machines. If living beings cannot cross interstellar distances, then probes will. Autonomous systems, immune to vacuum radiation and time, spreading through the galaxy without fatigue or fear. This is the final refuge of optimism. It appears logical, efficient, and inevitable. And it fails for the same reason everything else fails. Scaling does not forgive error. The concept of self-replicating probes assumes that engineering behaves like mathematics. One machine becomes two, two become four, and exponential growth fills the galaxy. But physical systems do not multiply cleanly. Every act of replication consumes energy, materials, precision, and time. Even biological replication, refined by billions of years of evolution, accumulates errors and collapses without constant correction. Machines fare worse. Radiation flips bits, thermal cycling fractures structures, micrometeoroids erode surfaces, and calibration drifts without intervention. A probe capable of manufacturing copies of itself in uncontrolled environments must carry not only tools but full industrial ecosystems. At that point, it is no longer a probe, it is a civilization compressed into hardware carrying the same vulnerabilities civilizations already possess. Error does not remain local in self-replicating systems. It propagates. A minor defect copied repeatedly becomes a systemic failure. Navigation inaccuracies amplify, resource miscalculations cascade, and control logic degrades across generations. Exponential growth magnifies failure faster than success. This is why nature suppresses unchecked replication everywhere it appears. Space does not provide a special exemption. It removes repair, feedback, and redundancy, accelerating collapse rather than expansion. The assumption that space offers unlimited resources is equally flawed. Matter is abundant, but usable matter is not. Mining asteroids, refining metals, manufacturing high-precision components, and assembling complex systems require controlled environments, energy gradients, and infrastructure. Even on Earth, with gravity, atmosphere, and ecosystems doing most of the work for free, advanced manufacturing remains fragile and resource-intensive. Space offers none of these supports. Every process must be recreated artificially, increasing mass, complexity, and failure points. At interstellar scales, efficiency losses dominate completely. Navigation across interstellar distances introduces another fatal constraint. Stars are not fixed targets. They orbit galactic centers, drift relative to one another, and interact gravitationally over millions of years. A probe launched toward a destination must predict the future state of a dynamic system across time spans longer than recorded human history. Small uncertainties do not lead to small misses, they lead to total loss. Course correction requires fuel, fuel adds mass, and mass multiplies energy requirements. There is no guidance network in the interstellar void, no reference frame immune to drift, and no margin for cumulative error. Communication does not rescue the model. Any signal sent home travels at light speed, arriving years, centuries, or millennia later. The originating civilization may no longer exist, may no longer listen, or may no longer understand the message it once sent itself. Information does not survive indefinitely without context, receivers, and continuity. A probe without an audience is not exploration, it is debris with a data log. If such machines were feasible, their presence would be unmistakable. Self-replicating probes do not vanish quietly. They leave waste heat, material signatures, energy emissions, and structural artifacts. A galaxy seeded with autonomous machines would not look empty. It would look industrial. Our observations show the opposite. Stellar systems behave naturally. Infrared surveys reveal no convincing large-scale engineering. The silence is not due to limited observation. It is consistent across methods and scales. This is why the question attributed to Enrico Fermi was never naive curiosity. It was a recognition that easy processes leave traces. When nothing is observed, the simplest explanation is not universal restraint, but universal constraint. Advanced does not mean unlimited. Intelligence does not nullify thermodynamics. Complexity does not defeat entropy. Every additional capability adds additional fragility. Speculative escape routes, warp drives, wormholes, exotic matter exist comfortably on paper because equations tolerate conditions reality does not. Stability, scalability, manufacturability, and causal consistency are not optional features. They are filters. Feynman's warning applies again. Mathematical permission is not physical permission. Nature allows many equations that never instantiate. When machines fail alongside biology, the conclusion sharpens. The universe does not prevent contact through secrecy or hostility. It prevents it structurally. Isolation is not an accident. It is the default outcome when energy, error, time, and distance are accounted for honestly. The absence of probes is not puzzling. It is exactly what physics predicts. This realization removes the last technological escape hatch. There is no hidden swarm moving silently between stars, no ancient machinery watching from the dark. The universe is quiet because sustaining purposeful activity across interstellar distances is not just difficult, it is unstable. What remains are isolated systems evolving locally, rising briefly and disappearing without successes. The silence is not waiting to be broken. It is the natural state of a universe that does not scale intelligence beyond its birthplace. After distance fails, biology fails, and machines fail, the final refuge of belief becomes intention. Maybe civilizations know about us and choose silence. Maybe observation replaces contact. Maybe the universe is crowded but cautious. This interpretation preserves meaning, but physics does not require motives to explain outcomes. Silence does not imply choice. Silence emerges automatically when contact is structurally unstable. Any civilization capable of understanding interstellar physics also understands risk. Information exposure is vulnerability. Broadcasting location, biology, or intent across cosmic distances offers no evolutionary advantage. Contact cannot be reciprocal in real time, cannot be corrected once initiated, and cannot be undone. In a universe governed by finite speed and irreversible causality, the safest strategy is non-participation. Silence is not fear or ethics. It is optimization under uncertainty. Expansion itself is often treated as an evolutionary imperative, but evolution rewards persistence, not reach. Moving into hostile environments multiplies failure modes faster than it multiplies opportunity. Every new system adds dependencies, delays, and uncontrollable variables. Stability favors locality. Civilizations that survive are not the most expansive, they are the most contained. Interstellar ambition increases complexity without increasing control, and complexity without control is how systems fail. Technological growth intensifies this problem. As energy access increases, so does the capacity for irreversible error. Nuclear weapons, engineered pathogens, autonomous systems, and information warfare are not anomalies. They are natural products of intelligence scaling faster than wisdom. The same capabilities required for interstellar engineering also enable self-termination. The interval between technological competence and existential fragility is narrow. Most civilizations likely do not cross it intact. This reframes the idea of a single great filter. Reality does not rely on one improbable barrier. It applies many moderate ones continuously. Ecological collapse, resource exhaustion, political fragmentation, runaway automation, and loss of institutional memory erode civilizations incrementally. Long before interstellar capability matures, coherence dissolves. Space does not eliminate civilizations. Time and internal dynamics do. The absence of galactic empires follows naturally. Empire requires sustained coordination across distances and durations that exceed cognitive, cultural, and institutional limits. Goals drift, incentives decay, meaning erodes. A project that must persist for hundreds of thousands of years fails not because it encounters resistance, but because it outlives relevance. The universe does not oppose empire, it simply outlasts it. Observationally, this conclusion is reinforced by thermodynamics. Advanced activity must dissipate energy and produce waste heat. Large-scale engineering cannot hide indefinitely. Infrared surveys, stellar monitoring, and galactic scans reveal no consistent evidence of widespread artificial structures. The absence is not due to insufficient sensitivity. It is uniform across independent methods. What is missing is exactly what should exist if interstellar civilizations were common and durable. The appeal to vastly older, godlike intelligences does not resolve the contradiction. Time does not grant exemption from physical law. It improves efficiency and optimization, but does not remove limits. Progress asymptotes, margins shrink, error never disappears. An intelligence millions of years old is still constrained by entropy, causality, and finite resources. Advancement sharpens limits, it does not erase them. This is the core of the Feynman reality check. Richard Feynman did not ask whether an idea was elegant or inspiring. He asked whether it survived contact with reality. Alien arrival does not fail because it is unimaginative. It fails because the accounting never balances. Energy costs explode, error accumulates, time desynchronizes, incentives vanish, and causality enforces isolation. The silence of the universe is therefore not ominous. It is expected. It tells us we are not late to a cosmic gathering and not excluded from a larger story. There is no larger story. There are only local narratives, briefly illuminated, separated by distances that erase continuity. Each instance of intelligence stands alone, bounded by its environment and responsible for its own survival. This realizing removes comfort, but adds clarity. No observers, no guardians, no inheritors. What happens here does not echo outward in any meaningful way, and nothing arrives to correct our failures. If intelligence persists, it does so locally or not at all. The universe enforces this outcome not through hostility, but through indifference. The most unsettling conclusion is not that we are alone, it is that everyone is. Intelligence may arise many times, but it does not converge, it does not meet, it does not accumulate into a cosmic mind. It flickers briefly, constrained to its island of matter and time, and then disappears without witnesses. The silence above is not waiting to be broken. It is the final condition of a universe that does not scale awareness beyond its point of origin.